Hello, this is chapter 6, video number 3, and today we're going to be going over the binomial distribution. Now, previous in this chapter, we have been introduced to discrete random variables where we have a specific value and a probability that goes along with each of those. And we solved some problems with it. Now we're going to go over a specific type of distribution, and that is the binomial distribution. So, a few things to say about the binomial distribution. This is when there are only a fixed number of trials. So, we have a fixed number of trials. We have a set probability, or I guess I should say fixed probability of success. And then finally, there can be two possible outcomes. Whenever you see the prefix by, that typically means two. We have two possible outcomes. And then finally, the results of each trial are independent. Fixed number of trials, there's a fixed probability of success. There are only two possible outcomes. And finally, the results of each trial are independent. So the most common binomial distribution that you think of is flipping a coin. There are only two possible outcomes, and let's say that I wanted to flip a coin 10 times. Well, then I could figure out what's the probability that I get one tail. What's the probability that I get two tails out of 10? Probability I get three tails out of 10, so on and so forth. So binomial, a lot of people think of coin flipping. I'm going to go with something else. Here's the example that I'm going to go with. I'm going to say that a basketball player has an 80% free throw percentage. And I'm going to say that the basketball player at the end of the day has to shoot 5 free throws. Before you leave practice, you got to shoot 5 free throws. So this player is shooting 5 free throws. And I want to go ahead and describe this distribution. So let's go ahead and create a table. So 1, 2, 3, 4, 5, 6. All right, I'm going to go ahead and name this random variable x. All right. And the possibilities here, we could have 0 makes. And actually, I do have to define what x is. Let's go ahead and say let x be the number of free throws made. All right, so let x be the number of free throws made. So our different possibilities, well, maybe you're having a really bad day and you could make 0. Or you could make 1 out of the 5 free throws, 2 out of the 5, 3 out of the 5, 4 out of the 5, and finally, what is the probability that you make all 5? Boom. So let's real quick go over to make sure that this is actually a binomial distribution before we start calculating those percentages. First off, fixed number of trials. Well, yes, we are shooting 5 free throws. Fixed probability of success. We are going to go ahead and assume that this player, every single time they step up to the line, when they go to shoot, they have an 80% chance of making it. Great. Two possible outcomes. Well, yes, you either make it or you miss it. And finally, the results of each trial are independent. This is an assumption that we're going to make here. I know sometimes, let's say that you miss a free throw and you start to get down on yourself, and that affects your next free throw that you try to make. We're going to go ahead and assume that no matter what, no matter if you've made or missed 10 in a row, it's still 80% for the next one. All right, so now we need to figure out the probabilities of each of these, Now, there will be an assignment at the end of this unit that will be an extra credit assignment. We're going to go over how to actually calculate these by hand. So that will be an extra credit assignment. Don't worry about it. You're not going to hear about it for another 2 weeks. But for now, we're going to go ahead and use technology to calculate these probabilities. So to our good friend Desmos. Our good friend Desmos will calculate binomial probabilities, but you need to actually know how to program this to do it. So the command for this is binomial dist, all right, and then you're going to go ahead and add parentheses. So binomial dist, binomial distribution, and it's asking for two things. It's asking how many trials are you doing, and what is the probability of success. So how many trials are we doing? Well, we are shooting 5 free throws. All right, and the probability of success, well, we have a probability of success of 80%, 0.80. All right, and we can go ahead and if you click these, I'm actually going to warn you it's not as accurate, but the probability of making all five is right around 33%, so 0.328. Probability of making four is 0.41%, 41%. Probability of making 3 is 0.205, and you can calculate the others. Now, I am going to warn you, the reason why I don't really like clicking on these points is because this is not actually accurate. No, it is not impossible to miss all of them. It's just it probably has several decimal places here. So the more accurate way to do this in Desmos is find the cumulative probability. So if I click this, boom, right now, we have a cumulative probability. What's the probability of making from 0 to 5? Let's say I wanted to calculate the probability of making all 5. Well, I'll go ahead and say, hey, what's the probability that I make from 5 to 5? And that is 0.32, and I'm going to go ahead and round that to the nearest 3, 0.328. So this one is 0.328. All right, probability of making all 4 of them. All right, oop, careful. Probability of making 4 would be 4 to 4, 0.410 if I round that correctly. So this is 0.410. For 3, 3 to 3, 0.205, 0.205. All right. I'm going to skip one. I'm going to go to 0. All right. And I love that we actually type this in. If we were to actually just go off of this, it says 0% chance of it occurring. It's not impossible. This is actually 0.00032. Now, I know I said I was going to go ahead and round these off to 3, 0.00032. I'm going to go ahead and go to 5 decimal places just so we can show, hey, this is not an impossible event. So I'm going to go ahead and ask for these two for a final question for you. What's the probability of making 1? What's the probability of making 2? But just like before, I want to tell you guys, this is a discrete random variable. This is a discrete. Our probabilities must add up to 100%, and our probabilities must be between 0 and 1. And sure enough, hopefully if you get the correct answers for 1 and 2, all of these should add up to 100%. The probabilities are all between 0 and 1. And this is a discrete random variable because there are a fixed number of values that this could take.